So we want to go back and link this to where we started last week. Okay, we want to make sure that we know why we're doing all this factoring and what it's for. So I'm going to give you a few steps to follow and put everything together that we've done so far. So let's go ahead and grab this. Now, what's the first thing you can grab right away without doing anything? Remember that this right here is the y-intercept. So c equals 3, which is the y-intercept. So right away, if it's given to you in standard form, you already know that, okay, y-intercept is 3. But besides that, I mean, we know it's going to open upwards because a is positive. So I know it's going to open like this, right? My vertex is going to be a minimum, remember. So if it opens up, the vertex is a minimum. Right? But that's, in standard form, that's all the information I can get. So that's why we want to go through and factor it to find the x-intercepts. So recall that everything you're doing with factoring is to find x-intercepts. So let's take this, factor it, and get those. So what two numbers multiply to 3 and add 4? That doesn't take too long because there's only two numbers that multiply to 3, right? 1 and 3. And if we did all the box or the distributive property factoring, we would get x plus 1 and x plus 3. The factored form. Now the nice thing about the factored form is that we can figure out where the x-intercepts are because, well, here's y equals to 1. This is 1 on the y-axis. This is y equals negative 1. So if I want to find where it crosses this x-axis, right in the middle, this is 0. So I set this equal to 0. And that's why we set it equal to 0 when we're solving before. That's where it crosses. Right here, the x-axis. So we did this, right? Said, well, if two things multiply and equal 0, one of them or both have to equal 0. So I can set both of these equal to 0 and solve. And I can figure out what those x-intercepts are. X equals negative 1. X equals negative 3. Two x-intercepts, negative 1, negative 3. And I use those braces, not parentheses. It's not negative 1, not the coordinate negative 1, negative 3. They're just two answers that are on the x-axis. I've got my negative 1 and my negative 3. Trying to get the picture of that parabola and slowly get there. So what is the axis of symmetry? Two ways to get that. What is the axis of symmetry? So you can look at the graph and see that it's going to be in the middle, right? So we know it's going to be negative 2 from the graph, but if not, you can always take your two x-intercepts and find the middle of them just by dividing them by 2, like the average. Add them up, divide by 2. So that's the middle as well, so we get negative 4 over 2, which is also negative 2. So two ways of doing the axis. Of course, if it comes out to be fractions and stuff, this is probably a more efficient way than just trying to figure out the fraction on the graph. Alright, and then we have the vertex. So we know the vertex, which is the minimum, is somewhere on this line. Don't know exactly where. Here, 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 way down here, don't know. You can figure that out. The axis of symmetry is the x-coordinate of the vertex. Remember that you have the axis of symmetry, you have part of the vertex. So just plug that in and see what you get. So I'm going to plug it in. that would give me the y coordinate of vertex. So negative 2 plus 1 is 1. Negative 2 plus 3 is positive 1. Negative 1 times 1, negative 1. There's my y coordinate. So negative 1, negative 2 comma negative 1. Notice how they're counted by halves here. It'll be right here. And we also get a bonus point because of symmetry. So if we extend this axis of symmetry, we can see the y-intercept. See how it's 4 to the right? So I have another point that's 1, 2, 3, 4 to the left. Because it's going to be the exact mirror image on both sides, I can get another point on the other side as well without having to do any calculation. 100% visual. And then you can draw your graph. Now remember, a parabola should not be vertical at any point. So if we go down here, not a V, there's no point down there. Crosses the y-axis right there. Remember, the graph keeps going outwards ever so low. So there is your parabola. So going back to why we do bonus factoring, it's just to get those two x-intercepts so we can do a much bigger, answer a much bigger question. How to graph. So first I did the y-intercept. Now if this number, like 3 was actually on here, but if it's some big number, you may not be able to do this. So this is kind of a bonus. Sometimes the y-intercept is, usable, sometimes not. You can always plug in any number as well into the factored form or the regular form and figure out some more points. We don't have enough. Let's practice one more, see how that goes. So that went. Yeah, let's try this one. Give that a go. Use the exact same steps we just did, and see how your graph turns out.
Okay, so on this first one, real quick we can see the y-intercept is negative 16. Alright. Go ahead and factor this. What two numbers multiply to negative 16? Add a negative 6. And 16, you usually probably think of 2 and 8 pretty quick, or 4 and 4. In this case, the 2 and the 8 will work fine. In order to get a negative 6, though, when we're adding, the 8 needs to be negative, and that will multiply to negative 16. So we know that this will factor to x minus 8, x plus 2. Now to find the actual intercepts, we set this equal to 0. Say x minus 8 equals 0. So x equals 8. And x plus 2 equals 0. Subtract 2 on both sides. X equals negative 2. So your two x-intercepts in braces would be negative 2, comma 8. Generally we put these in order from least to greatest, but it doesn't matter too much here. We keep on moving. We find the middle of those two. So we have negative 2 plus 8. Find the middle by dividing by 2. Find the halfway point. Alright, so that's going to be 8 minus 2, which is 6. And 6 divided by 2 is 3. So axis of symmetry is 3. And we keep on going. And we know that 3 is the x-coordinate of the vertex. So we're going to plug that into our factored form. So I'm going to have 3 minus 8 and 3 plus 2. So 3 minus 8 times 3 plus 2. negative 5 times positive 5. That equals negative 25. So the numbers here are a little bit bigger. And that's why on the graph, okay, then you go to the graph, I want you to sketch and label everything. So you don't have to do it to scale though. So I don't want you to do 1, 2, 3, 4, negative all the way to negative 25. But just start down here and say, okay, this is negative 25. That's my, oh no, that's not it. My vertex is going to be, let's say, right here, which is 3 comma negative 25. Right, that's my vertex. I know my y-intercept from the very beginning is negative 16, so I can graph that. And you're just estimating. If this is negative 25, negative 16, maybe right here. And label that. And then you have your two x-intercepts of negative 2 and positive 8. So negative 2 maybe right about here, positive 8 right about here. Then we have also the axis of symmetry that goes down the middle at 3. We have that on there. So when you're graphing these two, it should axis of symmetry should be in the exact middle. And don't forget, because of the y-intercept, you have another point on the other side here, which you don't really need to label, but you can see visually that there'll be another point there. And then with all that, you can go through and draw an estimated graph that's not exactly to scale, but pretty darn close, right? Just remember your parabolas, they never go exactly vertical. They always go a little bit outward. So just do that process with the next 3, and it's okay if you get fraction x-intercepts as well. You might get some fractions, that's okay. You can still find the middle and everything.